Okay, so what we would like to do now is just an example of taking a linear system and taking its augmented matrix and reducing it so as to solve it. And so first, just a little bit of terminology. A system, a linear system, is reduced if its augmented matrix is reduced. And why is that, or where does that vocabulary come from? Well, let's consider something like this matrix. This is a reduced matrix. The leading term of each row is non-zero term is 1. Above and below each leading 1 is 0, and each 1 is to the right of any 1 above it. Now this corresponds to the system x1 is equal to 2, x2 is equal to 4, and x3 is equal to -5. So in fact this system just tells us what the solution of this thing is. So if we can get a matrix to reduced form, then we are left with a system which basically just tells us the answers. We'll see some cases where a reduced matrix gives us something a little bit more complicated, but for the time being we're going to be working with something like this where we actually get down to just you know, an actual solution. So our example here is we would like to solve the following system. The system is we've got -3x1 plus x2 minus 2x3 is equal to 0. Let's see, what else? I already messed this up. That's not what I wanted. I wanted to have instead 4x1 minus x2 plus 3x3 is equal to 0, and then -3x1 plus x2 minus 2x3 is equal to 2, and finally just x1 minus x2 minus 2x3 is equal to 4. So this is a system of 3 equations in 3 unknowns. Now when we get the augmented matrix, the number of rows will always be equal to the number of unknowns, but the number of columns will be one more than the number of, the number of rows will always be equal to the number of equations, one row for each equation, but the number of columns will be one more than the number of unknowns. This part of the augmented matrix will have one column for each unknown, but then the last part has the the values on the right-hand side of the equation. So we have one more column than the number of unknowns. Now to get the augmented matrix, we take the coefficients of each row. Here it's 4, -1, 3, and 0, so I put 4, -1, 3, and 0. The next one is -3, 1, -2, and 2, -3, 1, -2, and 2, and the last one is 1, -1, -2, and 4. Okay, we would like to get this reduced, and so the first thing we want is we want the upper left-hand corner to have a 1 in it. Right now we've got a 4, and yes, I could divide the whole thing through by 4, but then I would end up with fractions, and fractions are not nice to work with. But since I do have a 1 in the lower left, I can swap the first and the third rows in order to get a 1 in the upper left. So first let's swap rows 1 and row 3. So what happens when we do that? We get 1, -1, -2, 4, -3, 1, -2, 2. Row 2 stays the same, and our new row 3 is the old row 1, 4, -1, 3, 0. Great. Now the second thing we need is that above or below any leading 1, we have to have zeros. But below this we have a -3 and a 4, so I'm going to have to change this to a 0 and this to a 0. The way that we're always going to do this is we're going to add a multiple of this top row to this guy and a different multiple to this guy to change this -3 into a 0 and this 4 into a 0. So what we're going to do is we're going to add, well, what times 1 minus 3 gives me 0? 3 times 1 minus 3 gives me 0. So 3 times row 1 to row 2. And we're also going to add 1 times -4 plus 4 gives me 0. So we're going to add -4 row 1 to row 3. Now let's do this computation carefully. 3 row 1 is equal to 3, -3, -2 times 3 is -6, and 4 times 3 is 12. So when I take 3 row 1 and add it to row 2, what do I get? 3 minus 3 is 0, -3 plus 1 is -2, -6 minus 2 is -8, and 12 plus 2 gives me 14. So that's my new row 2. My new row 3 will be -4r1 plus the old row 3. -4r1 is -4 times 1, which is -4. -4 times -1, which is 4. -4 times -2, which is 8. And -4 times 4, which is -16. And when I add that to row 3, what I end up with is -4 plus 4 gives me 0. 4 minus 1 gives me 3. 8 plus 3 gives me 11. And -16 plus 0 gives me -16. So what I end up with is the matrix that looks like this. The top is still 1, -1, -2, 4. But the next row is 0, -2, -8, 14, coming from this right here. And the last row is 0, 3, 11, -16. So we've accomplished what we wanted, which is below this leading 1 we have zeros. Below this leading 1 we have zeros. Okay, let me take a second to erase this while discussing what we're going to be doing next. The next thing we want to do is look at the second row. To get it reduced, we need the first number in the second row to be a 1. But right now the first number in the second row is -2. So how can I change the first number in the second row right here to be 1 without messing up the fact that I've got a 0 here? The only thing I can do is multiply or divide this row by something. So we're going to replace row 2 with, well, if I want to get rid of -2 and get a 1, I can divide -2 by -2. So I'll replace it with row 2 divided by -2. What do I end up with? The top row stays the same, 1, -1, -2, 4. The middle row changes, 0, 0 divided by -2 is 0, -2 divided by -2 is 1. Let me rewrite that. -8 divided by -2 is 4, and 14 divided by -2 is -7, and the bottom row stays the same, 0, 3, 11, and -16. Now that we've got a 1 here as the first non-zero term in the second row, I need to get everything above it and below it to be equal to 0. So to accomplish this, I'm going to replace row 1 with, well, if I want to take a multiple of 1 and add it to -1 to get 0, I just take 1 plus -1 and I get 0. So if I take row 2 plus row 1, 1 minus 1 gives me 0. So row 1 will now be row 2 plus row 1. I also want to replace row 3 with, well, I want a 0 here. -3 times 1 plus 3 gives me 0. So -3 row 2 plus row 3 will give me what I am looking for, because -3 times 1 plus 3 gives me 0. So then, what do I end up with? Well, row 2 plus row 1, I can just write that down immediately. 0 plus 1 is 1. 1 plus negative 1 is 0. 4 minus 2 is 2. And negative 7 plus 4 is negative 3. For negative 3 row 2 plus row 3, I'm going to be more careful. Negative 3 times row 2 is equal to 0, negative 3, negative 12, and 21. And so when I take negative 3 row 2 and I add that to row 3, I end up with 0 plus 0 is 0, negative 3 plus 3 is 0, negative 12 plus 11 is negative 1, and negative 16 plus 21 is equal to 5. So what this leaves me with is 1, 0, 2, negative 3, the first row coming from this expression. The middle row stays the same this time, 0, 1, 4, negative 7, and the bottom row becomes 0, 0, negative 1, 5. Okay, again, to get this into reduced form, I've got a leading 1 here, a leading 1 here. This row, the first non-zero term, is negative 1. I need it to be a 1, so in order to change negative 1 into 1, I'll multiply by negative 1. So we're going to replace the third row by the negative of the third row. And what does this give us? This gives us 1, 0, 2, negative 3, 0, 1, 4, negative 7, and 0, 0, negative 1 times negative 1 is 1, and negative 1 times 5 is negative 5. Great. So now I've got all of my leading non-zero terms are 1s. The only problem is above this one I still have non-zero things, so I still need to get rid of these guys, turn them to 0. And again, the way we do that is we add to each of these rows a multiple of the bottom row. Let me just briefly erase this down here so I've got something to work with. Okay. So I have to, if I want to get this 2 to be a 0, negative 2 times 1 plus 2 gives me 0. So we're going to add negative 2 times row 3 to row 1. And we're also going to add, since I want to get a 0, right here, 1 times negative 4 gives me negative 4, plus 4 gives me 0. So add negative 4 row 3 to row 2. What is, let me just sort of cut to the chase here and do things a little bit faster. Since I have zeros here, it's not going to affect the first two entries of row 1, but negative 2 times 1 plus 2 gives me 0. That's what I'm trying to accomplish. Negative 2 times negative 5 is 10, minus 3 gives me 7. Over here, 0 and 1 stay the same because 0 plus 0 is 0, 0 plus 1 is 1. Negative 4 times 1 is negative 4, plus 4 gives me 0. And negative 4 times negative 5 is 20, which minus 7 gives me 13. And the last row stays as 0, 0, 1, negative 5. Okay, this is reduced. Why? Because the leading non-zero entry in every single row is a 1. All of the entries above and below any of the 1s is a 0. And the ones, any 1 is to the right of any 1 above it. So this corresponds to x1 is equal to 7, x2 is equal to 13, and x3 is equal to negative 5, and that is our solution. And I encourage you to go back and check that that is actually the correct solution. I guarantee that it is. Booyah!